Okay, it is 2:10, everyone. Good afternoon, good morning, good evening, wherever you're joining us from. My name is Mosumola Olabelo, also known as Mo. I'm the community manager of Testes Quarters, and you're welcome to our monthly mentorship program. Yeah. So we have to start now. If you're new here, you would know by now that this one is something to always look forward to because we don't play here. Trust me when I say this would be one of the best you've had this year. Okay, so who are we? We are testers quarters. Okay, just give me a few minutes. Um, okay, so sorry about that. Let's continue. Um, we are testers quarters and we help you thrive and grow. The quarters or testers. Who are we? We are the most active software testing community in Africa, and we are focused on empowering, aspiring, and practicing product quality engineers with resources, support, mentorship that is required for them to succeed in their career. Yeah, this is our founder, Ibiroge Kene. She's an distinguished leader in software testing. She's a CVO. She has an HND in computer science and a BSc in computer science also. She also has a master's degree in cybersecurity. And apart from the fact that you always hear about Texas quarters, I'm very sure that there are some people that would be hearing about Testify Limited. Testify Limited consists of ABC, that is academy, business, and community. This is the community of Testify, which is Tester Sporters. Once again, you're welcome to Tester Sporters. Meet our community. We have different communities under us. We have different branches. We have the Tester Quarters Ethiopia, Tester Quarters Cameroon, Tester Quarters Kenya, Tester Quarters um, Uganda, Texas Quarters, Lagos, Ibadan, Abuja, Ghana. We have Avon MIT, that is Mothers in Tech. We have Avon WIST, that is Women in Tech. We have Texas Quarters UK, and we have Testify Academy Alumni Network. Our mission is to empower and elevate product quality engineers across Africa and globally by providing education, mentorship, industry collaboration, and career opportunity in software quality engineering. We aim to bridge the gap between testers and product excellence, positioning product quality positioning product quality engineers as strategic partners in the software development lifecycle. Our mission is to be the number one hub. Is to be the number one hub for product quality engineers in Africa, fostering a vibrant community where PQ is learn, collaborate, and drive software excellence while advancing the culture of quality assurance across the Africa tech ecosystem. Our objective and goals is to have over 10 local chapter across Africa, which we actually have now. We have more than 10 chapters in Africa. We have continental PQE Summit and Mentorship Network. We have globally aligned PQE training and certification. We have job board. We have universities. We have rebranding testers, as strategic product quality engineers. We have research advocacy and thought leadership. We have digital tools, PQE, dashboard, match, and more. Our programs, as we know, we have the QA office hour, which happens every Wednesday by 1 p.m. And this is a point where quality assurance engineers comes together to bring in their problems that they're having in the office, or if there is a tool that they are using and they think quality assurance engineers are going to um, their work is going to be faster after getting into this tool. I mean, you don't want to miss our TQ office hour. Either you're a newbie, intermediate, junior, senior, whatever you are, they are experts on this call, ready to answer your questions. And trust me when I say, whatever your problem is, it will be resolved in less than 3 to 4 minutes. Trust me when I say that. We have the study body, which is Friday, 8 p.m. Our chapters are currently doing that, where they bring up webinars every Fridays. We have the global AMA fireside chat every Saturdays. That is the mentorship that we're having today, is also fireside chats. We have the local community quarterly hangouts, monthly. If you know about APCEC, that is coming up very soon, just so that you are in for it. APCEC is one of our quarterly hangouts. Not like hangout, it is more of us coming together. This is online, where we speak and deep dive into quality assurance engineer courses. So yeah, you don't want to miss our hangouts. There are physical hangouts. We have hangouts in Lagos. We have hangouts in Abuja. And trust me when I say, you don't want to miss our hangouts. We have the annual gathering and conferences. We have the NSTW coming up very soon. We have different annual gathering that we work in, and trust me when I say, you don't want to miss that too. We have our IG, LinkedIn, and X live. During the course of this webinar, I'm going to be posting our IG and do our LinkedIn and X and do. We have fun, comedy, and movie nights. Yeah, we do that. We have testathon. There are some times that we can bring up something in the community for people to test and just check it out. We have test merchandise. Yeah. We have our core engagement, which I have spoken about it before. Now, this is our social media handles. So yeah, let me move on to introduce. Let me move on to introduce our speaker. Okay, so sorry about this. Okay, this is having just give me a few minutes, please. Okay, this is wonderful. Hi guys, give me a few minutes, please. I don't know what is going on with this. Oh, let me continue this. Okay, guys. So, apologies on that. I guess the laptop was acting up, but yeah, let's move on. So, as we know, our speaker for today is Alexandra Michael. And trust me when I say that it is going to be wonderful because I have seen it. And trust me when I say you don't want to miss this at all. Okay, we have Alexandra Michael. Okay, she's a detail oriented software QA tester with experience in end-to-end testing of web, mobile, and ERP platforms, skilled in functional regression, UI UX, and integration testing. That is the REST APIs Google workshop. With designing or executing test cases, tracking bugs, ensuring data integrity. Okay. Experience in validating complex workflow, authentication flows, and multilingual support while collaborating with developers and product manager to improve product quality through structured QA reporting and smooth deployment. Beyond her professional work, she also volunteers as a youth coach, supporting and mentoring young people in their growth and development. Hi, Alexandra. How are you doing? Can you hear me?
Yes, I can. Good
Oh,
afternoon.
good
Masala.
afternoon. Okay, good afternoon. It's so great having you here.
I thank you. Thank you for that wonderful introduction.
My pleasure. So, I know the topic for today is about risk. Um, So let me put this on the screen so people can see it clearly. Yeah. So it's about risks and prioritization. And I'm very sure that VQAs understand what we're talking about, but with that, we're going to be digging into this topic. And trust me when I say you want to listen attentively. But before we get into that, we would like to hear a little bit about Alexandra. I see that when I was checking it out, I got to notice that she had more than 6 years experience, and it is interesting because I saw that even as she's going into software testing, she also have some other things that I could see that she got into. So if we can just hear a little bit about Alexandra, we don't mind. Over to you, Alexandra.
Okay, hi everyone. Good afternoon. Thanks for coming, attending this session. Let me just go through with my introduction. As um Mosumola has already stated, she has already read a lot about me. So professionally, my name is Alexandra Michael. I'm a quality assurance engineer with years of experience in both manual and automation testing. I've worked with a lot of industries such as the fintech, um, ERP, and e-commerce and the likes. Like I can't list all of that. So I've worked with a lot of tools as well. So I'm conversant with a lot of tools. So aside quality assurance in general, if you really want to know a bit about me, I'm someone that is passionate about fashion, writing, and the likes. I try to publish few articles like weekly. So that's what I do mostly in my spare time, aside trying to look for bugs. So basically, that's all about me. I think you guys have heard a lot about the my experience and the likes and what I can do and what's not. So basically, that's it.
Thank you very much for that introduction. It's really great to hear some things about you.
Thank you.
Talking about fashion and QA, how do you shift between this? I hope you don't mind us getting into you before we get into the topic.
Yeah, I don't mind. Like I try to strike a balance between either work and life in general. So I try to equally do what I'm passionate about. It doesn't need to be monetized or it doesn't need to be a career. Let me say, for instance, some people might feel that content, if you're a content creator, for example, you have to fully be a content creator. But I don't look at life in that view. I just look at it that anything I am really passionate about it, there's not there nobody should stop me. I can just go for it. So since I'm passionate about testing, making sure that product reach is high quality, I made it my career because I love it. I want to continue doing it. Then for fashion, I just like I dress daily. I don't need to wait for an occasion to show that I really enjoy fashion and dress ups. Then equally for my writing, I equally write. So you can meet me anywhere. Some people might know me as a writer, most people know me as a QA. And on Instagram, basically, they might know me as that fashion girl. So depend on the platform that you meet me. If you meet me on LinkedIn, you know that I'm that QA girl. You meet me on Medium, that writer, and on Instagram, that fashion girly. So it's all part of me. So I enjoy doing it. So it doesn't look stressful at all while doing it. I just like create a balance between all of it. Mosumola, over to you.
Okay. So sorry about that. Okay, so apart from your introduction, it's so great learning more about you. So let's go into the topic. May I ask what risks is what risks means in software testing? Like what should we define risks as in software testing?
Okay, yeah, for risks, first off, if you think about risks, risk is basically just the possibility that something could go wrong combined with the impact it could it could have or it would have if it did. So anytime like as a tester you think of risk, it just know that it has not happened, but it's just the possibility that something could go wrong combined with the impact it would have if it did. So basically that is what risk is all about. And I don't know if I'm currently giving the floor to proceed with the entire topic or the entire session.
Okay. Oh, okay. Do you want to like share your screen or you just want to speak about it?
Okay, I just have a little slide highlighting some of the key points. So I will just share it while I talk about
Okay, great. That's
talk about it. That's
okay.
fine.
Okay, that's fine. You can share your screen. Thank you.
All right. Mm, okay. So give me a moment. Share my screen. Okay. Okay.
Mhm. Okay, while we're waiting for her, I would like to say that if you have any question at all, you can always raise up your hands. Use the hand icon to raise up your hand, and then we can give you the floor to speak. Thank you very much.
Okay. So risks and prioritization in software testing. So our testing focus is we do not test everything. We focus on areas that can break the business. The goal is ensure confidence in critical features like payment, login, and core workflows. And approaches use risks to guide what to test deeply versus lightly. I know this might sound vague. That's where I'll just like come in and throw the introduction. So now in this section, what is expected for us to be able to for us to understand at the end of the session is that we should understand what risks means in the context of software testing, identify and classify risks using structured frameworks, applying prioritization techniques to build smarter learner test strategies, avoid common prioritization anti-patterns, and design a risk-based test plan for a real-world scenario. So while I go through this, I will just walk you all through the entire process. And if there are any questions, you can equally just call me back or drop it in the chat box. It can be attended to by anybody. The other facilitators, or I can equally look at it. So now let's go back to the problem, why prioritization matters. The painful reality of testing is that you can never test everything. The question is not whether to prioritize, it's whether you do it consciously or accidentally. Let's all know that there's always more to test that time allows. Not all features carry equal business values. Bug in some areas cost 10 times more than bugs in others. Testers who don't prioritize end up testing what is convenient, not what matters. Testing without risk analysis is guesswork disguised as process. So now I want to ask everyone a question. Just think of a time when a critical bug was found by a customer that your team missed. What area was it in? Was it tested? And why was it missed? That's what us as QA should ask ourselves. I know how painful it can be when a customer discovers a bug and we have tested it. So when we don't prioritize accordingly and we don't look at the risk areas, this is what is going to happen. So this class is going to walk us through all of that. Is well detailed. So I just advise that if we have our books and pen, we can take notes of what we want to take note of. And I know the class is already being recorded. We can also have like the video so we can go through it once again. And this class have equally answered a lot of questions that were asked before the class. I try to merge everything into my class. There is something called the testing iceberg. So the testing iceberg shows what we test, which is visible to us users, what we plan to test but didn't because time ran out, and what we never even considered testing. And most of times, what we don't like, what we test is mostly the UI, what we see. And we miss bug that live below the waterline, which is what we never even considered testing. In areas testers deprioritize consciously or not, like you feel you don't deprioritize, but you've ended up with deprioritizing. So here, risk-based testing forces you to look below the surface systematically. Understanding risks in software testing. Risks, just like I have explained earlier, is the possibility that something could go wrong combined with the impact it will have if it did. Looking at risks, you can calculate it the formula as risk exposure equal to likelihood of failure times impact of failure. I can come again. You calculate risk exposure by likelihood of failure times impact of failure. So right now we can take note of the important distinction to make some terminologies clear, because we tend to mix it up sometimes as testers. So there is risk, issue, and defect. Risk is a future uncertainty, something that might happen. Issue is something that has already happened, a bug found. When you find a bug, that's an issue. And defect is a specific flaw in the code of design. Now there are different types of risks. And before I move to the types of risks, as testers, since we often confuse the risk, issue, and defect, I just want us to have risks in mind, that risk is always about the future. It has not happened. It's just the possibility. So that's the only thing that should be glued in our mind when we think about risks. Now let's proceed to the types of risks in software testing. There are two major types of risks, which is the product risks, and the product risk is more from the quality risks. Risks that the software itself won't work correctly for users. For example, a payment gateway fails under load, login feature breaks on Safari, data migration corrupts customer records, accessibility features don't work for screen readers, API returns incorrect values for edge case input. So those are the risks associated with product risks. Now, the second type of risks is the project risks, which is a process risk. These are risks that affect the testing effort itself. Now, for some example of it are requirements are incomplete or changing. The test environment is unstable. The key tester is on leave during release week. Test data is not representative of production, and the automation suite is flaky and slows down everything. So let's always remember that why most testers only think about product risks. Project risks can silently destroy test coverage. So basically, product risks, I know what I've just explained. I just try to go in details so we don't miss out on anything. So I quickly want to run over this again. When you hear of project risks, just think of process risks. What happens in the process? Then when you hear of product risks, think of quality risks. Now I need to proceed to the next section, which is the risk equation. Right now, let's break it down. So for the risk equation, we have the likelihood of failure and impact of failure. Let me go through the likelihood of failure first off. The likelihood of failure, QAs should ask these questions. How complex is this feature or code part? How recently was the area changed? How experienced is the developer who built it? Has this area had bugs before? That's the defect density. Is it a new feature or a legacy component with technical depth? Is the code well tested at the unit level? Were there unclear or changing requirements during development? So these are most of the questions QA should ask in likelihood of failure. What can actually cause a failure? Then the next one is the impact of failure. QA should ask this question: how many users will be affected? Is this on a critical user journey? Example, the sign up, checkup, core feature, core workflow. What is the financial or legal consequence of a failure here? What is the reputational impact? How severe would the failure be? Will it result to a cosmetic versus data loss or security breach? We should know the severity of like that particular failure. Is there a workaround available if this breaks? And how visible is this area to senior stakeholders or regulator? These are the basic questions as QAs we need to ask so that we can well know what we are working with and how to calculate how it fall into the risk equation. So let me go ahead. If you have any question, you can just raise your hand and ask, or you can equally ask me to come back if I'm too fast. Now I want to proceed to the impact of failure. QAs should ask this question: how many users? Okay, I've covered likelihood of failure and I've covered the impact of failure. Now we should proceed to the risk classification models. So there are various types of risk classification models, up to 3 that I actually noted. So for the first model, the first model is the risk matrix, which is the 2 times 2. The first one is the risk matrix, which is the 2 times 2. So here, unfortunately, I don't have a lot on my slides, so I'll read it out. And if the material is needed, I can equally share to the group to look at it as well. So for the risk matrix, we have low likelihood, which is the impact is low risk, and high impact is medium risk. Then we equally have the high likelihood, which the low impact is medium risk and the high impact is high risk. So let me interpret it, because it will seem as though like it's being scattered. So I want to interpret it so we can have clear understanding of what I meant by the risk matrix. I just read out the table. So the interpretation is that the low likelihood plus low impact equals minimal risk, usually acceptable. So we can note that down. Low likelihood plus low impact equals minimal risk, usually acceptable. Then low likelihood plus high impact equals monitor closely, create contingency plans. High likelihood plus low impact equals manage through routine quality activities. Then high likelihood plus high impact equals critical risk, which requires immediate mitigation or testing focus. So we can really take note of this to use it to work on different features we are working on, like on our products. So now I want to go into the second model. Trust me, it gets like a bit practical when I get there. I'll always keep calling these models that have been used for the later practicals in front. So for the second model, we have the risk score table, the numeric risk score table. So here, we assign a score 1 to 5 for likelihood and impact, then multiply. So likelihood is how likely is a defect to occur, and impact is how bad is it if it occurs. So I can go again. Likelihood is how likely is a defect to occur, and impact is how bad is it if it occurs. Then you compute. Risk score equals L times I, which is likelihood times impact. Then you can have a range of like 1 to 25. It depends on how you want to like calculate it. So let me just go into what it will look like technically. So when the score is 1 if the likelihood level is very low. So the criteria is stable, rarely change, or no recent bug. The score is 2 when is low. So now I'm rating from 1 to 5. So the score is 2 when it's low. Here, the criteria we have minor change and low complexity. And the score is 3 when the likelihood level is medium. The criteria, there's moderate complexity, occasional defect. When the likelihood level is high, the score will be 4. And the criteria is complex logic, frequent changes, and past bugs. And for score 5, the likelihood level is very high, where the criteria is new feature, unstable, many defects, unclear requirements, etc. So let me give an example of a real life product. For instance, we have like a payment payment processing flow. The likelihood is going to fall under 3 because it falls under medium. Then the impact is going to be 5. I know we talked about impact earlier. Then this risk score can be equals to 5. Now let me go back to the calculation. Risk score is equal to likelihood times impact. So that's what we did. The likelihood is 3 times the impact 5, which is 5 times 3, which is equals to the risk score 15. Then the priority is high, which is P1. So that's the way I just like categorize this based on the risk score and the impact level. So just like I mentioned, if you have any question about the calculation and the likes, it can be dropped because these formulas equally help you structure and create a very well detailed risk documentation. Now, the last but not the least is the third model, which is the failure mode and effect analysis. This is used in high-stake industries such as medical device, aviation, and the likes. And the scoring is done in like 3 dimensions. For the first dimension, we have the severity. The next one is occurrence and detectability. You can just use the shortcut SOD. So each of them, S stands for severity, O stands for occurrence, and D stands for detectability. So the severity, the meaning is how bad is the impact. We can scale that from 1 to 10. Then occurrence is how likely is it to happen. We can equally scale that from 1 to 10. Sorry, did someone raise up their hands?
You can just continue. Okay. Thank you so much for such a wonderful piece. Though I can be very much.
Sorry, I can't hear your voice very well.
Richard,
Yeah.
I'm sorry about that, Alexandra. Richard, I think it is only at your side because I can hear her clearly. Thank you. You can move on, Alexandra.
All right, that's fine. We already have it's recorded, so I think we might be able to get the recordings afterwards. So let me just go through the failure mode and effective analysis again. So the dimensions, like I mentioned, we have the SOD, which is severity, occurrence, and detectability. So severity is how bad is the impact. That's for severity. Occurrence is how likely is it to happen, and detectability is how hard is it to catch. So we can scale all of this from 1 to 10. 10 equals hardest. So the RPN, this is a different formula I'm giving, which is risk priority number is equals to X times O times D, which is severity times occurrence times detectability. So high RPN, that means high risk priority number equals test first and test deep. So when the severity and occurrence detectability is really high, you just know that you literally have to test first and test deep. That particular feature, we're talking about a feature right now. So when to use FMEA method? When you hear me say FMEA, it means failure mode and effect analysis method. So when to use FMEA? So we use it for regulated industries, safety critical features, or anywhere a missed defect has catastrophic consequences. So now I want to move to a different part entirely because I've covered the first part, which is the risks. Now, let's move to prioritization. So, prioritization frameworks and techniques. First off, we have to look into bricks-based test prioritization. So, this is the central approach of this section. So, the principle is that we should allocate your testing efforts proportionally to the risk exposure of each area. So that's the principle of the bricks-based test prioritization. Make sure you allocate your testing efforts. So make sure you allocate your testing efforts proportionally to the risk exposure of each area. So high risk areas equals more test cases, deeper coverage, exploratory testing, regression, coverage, etc. And for the low risk area, there are fewer tests, smoke tests only, or skip entirely. This is where you prioritize. Now, there are key shifts for our mindset that I just want us to focus on right now, which is our old mindset versus our new mindset. So for our old mindset, we will say that let's test everything. That's basically how when I came into join the tech industry, that was what was in my head. Let's test everything. Definitely everything is important. But the new mindset is let's test the right things deeply. For old mindsets, coverage is the goal. Our new mindset should be confidence in high risk area is the goal. Our old mindset is currently we test what developers built. Now I'm telling you that our new mindset should be we test what user depends on most. Our old mindset is we test in order of the spec. Now our new mindset should be we test in order of risks. So that's where prioritization actually comes in. Now, the next prioritization technique is the Moscow plus risk overlay. So this is to combine the Moscow method with risk scoring. So Moscow right now stands for must test. The must there is must test. The score is should test. The S is should test. The CO is could test, and W is won't test. So the must test is you have to test all critical paths. The critical paths must have full coverage before release. Then you should test. Important is very important, but not release blocking if missed. Then for code test is a nice to have. You have to you can test it if time persists and permits you to test. Then won't test basically this in a particular cycle is explicitly deferred documents then just fully document the decision. So for the won't test, there are very negligible features that it has no impact in the product. So it can be moved to the next sprint and you can just document that you document your decision that particular feature was not covered. Now, how to apply the Moscow method? You first list all your test areas or features. You first list out your test areas or features. Then score each for risk for the risk, which is likelihood times impact. I've given you guys the formula for that, but if you want us to drop it in the chat later or the full document, you can get that as well. So you score each for risk, likelihood times impact. Then you map score bands to the Moscow categories. Then finally, you assign testing efforts accordingly. So now I want to give an example for the scoring bands. Let's say the risk score is around 15 to 25. So the Moscow category should be must test because it's really high. The risk score is really high. 15 to 25 is high. So the Moscow category should be must test. Then the testing approach is full coverage plus exploratory testing. Then if the risk score falls under 9 to 14, the mass score category should be should test. And the testing approach is functional and boundary-based testing. Then when the risk score falls under 4 to 8, the mass score category is cold test. Then our testing approach should be smoke and happy pass only. Then if the risk score falls under 1 to 3, the mass score category should be wound test. We just document and skip for our testing approach. So if you want me to come over this again, I think I'll just run through it again so that we'll have full understanding. So the risk score, just like I mentioned, was gotten from likelihood times impact. We can drop the formula so we know how to calculate it. Now, if the risk score is around 15 to 25, you must test. Is around 9 to 14, should test. 4 to 8 could test, and 1 to 3 won't test. So the third technique, prioritization technique, is now the 80-20 Pareto principle. Let's have this in mind that roughly 80% of the bugs will come from 20% of the code base of the system. How to identify that 20%? So the defect history, where have most bugs been found historically? That's what you look out for. Then the next one is the code complexity. Which modules have the highest cyclomatic complexity? Then you look out for the change frequency. Which areas change most in this sprint? User traffic. Which features do 80% of users which features do 80% of what users actually use? Then the last one, not the least, is the business criticality. Which features generate the most revenue or handle the most data? So this is how we identify that 20% of system. So I believe with this, at least we can have we can say we have an understanding of the 80-20 parental rule principle. So now I want to move on to the next technique, which is the coverage risk matrix. Now I will try to be a little bit faster because I have a lot to cover with little time. So coverage risk matrix, that's the next prioritization technique. So for this coverage risk matrix, most times what we did basically is to try to identify the dangerous gaps. That's what we try to do. So for high coverage, for instance, high coverage, when there's high coverage and the risk is the high is under high risk, what we do is maintain and monitor. Then but it's under low risk, that means lower priority. Then for low coverage, high risk is top priority, low risk is nice to have. So I will go through this in a different angle. So for this particular coverage and risk, what we are basically meant to do is to focus on areas with high risk and low coverage. These are the most dangerous gaps because failures are likely or costly. Testing is currently insufficient. Then the danger zone is your immediate priority. The potentially over-tested quadrant is where you can reclaim time. So right now, I can ask a quick question. We can just drop the answer in the chat box so that we can move on quickly. So a quick question. Have you ever seen a team spend enormous effort testing something low risk while a high risk area was barely covered? What caused that? Let me just go through the question again. Have you ever seen a team spend enormous efforts testing something low risk while a high risk area was barely covered? what caused that. So right now, in my own perspective and what I've seen so far, most reason is as a result of familiarity, convenience, vocal developers, legacy test suites never updated. That's the major reason people stick to testing, like testing low risk area, putting effort on low risk area, why the high risk areas are not covered. But you can literally drop your perspective and to this particular question. Now moving on to the next prioritization technique, which is the test case prioritization for regression. Now, when you have an existing test suite and need to decide what to run, use these ordering strategies. So the first strategy is change-based prioritization. We have to run tests that cover code changed in the release first. Use different analysis or code coverage tools. Then the second technique we should use is the defect history prioritization. Here we have to run tests that have caught bugs before. Tests that have never found a bug are candidates for removal or redesign. Another angle is risk score prioritization. We have to order test cases by the risk score of the feature they cover. And the last one is time constraint prioritization. Now, given a budget, let me say, for example, 2 hours for regression, because most times that's what we get as QAs. We have very short time for us to complete testing. So if you are given 2 hours for regression, run the highest priority test first, so that if time runs out, you've covered what matters most. Like, I can repeat that over and over again. When you're given like a budget, like a very short time for your regression, run the highest priority test first, so that if time runs out, you've covered what matters most. So there is an anti-pattern to call out, which is running tests in alphabetical order, high order, or the order they were written, with no relationship to risks whatsoever. Like, I've been a victim of this particular pattern initially when I just joined, because I was trying to get the entire, I felt that I can test everything. So you can just test based on the features. I always have a list. I know most people have a list of the features they test, and they keep testing in that pattern, not minding where is high risk or low risk, so they can prioritize accordingly. I think we should stop that. Like, since we are in this class right now, we've known better. We should stop that and prioritize accordingly. So the next part of this session is the risk-based test planning. So this is where you build a risk register. This is where you build a risk register. So a risk register, I know this is the first time most of us might be hearing about it. So let me expatiate on what a risk register is. A risk register is a living document that captures and tracks identified risks. I'll go over it again. A risk register is a living document that captures and tracks identified risks. So the columns that are needed for this risk register, the first one is the risk ID. That's your unique identifier. You need your feature or area, anything you call it, either feature or column or area or module, anything you want to call it. What part of the system? That's like the part of the system. Then you need your risk description, which is what could go wrong. For part of the column, you usually need the likelihood 1 to 5, probability of failure, impact 1 to 5, consequences of failure, risk score, we've already known the calculation, likelihood times impact. That's how you get your risk score. So when everything is in a tabular format, you are going to see that after your likelihood impact, you just like take the number, your likelihood times impact, and you've gotten your risk score value. Then Mitigation, testing, how you plan to test it. Ownership, who is responsible. Status, open, mitigated, accepted. That's what you have under the status. So let me run through the columns again without describing it so we can know what we need to have in our risks register. So for the risk register, what we need to have in the columns section before we can populate it with data is the risk ID, feature, risk description, likelihood 1 to 5, impact 1 to 5, risk score, which is likelihood times impact, mitigation, owner, and status. Let's all note that the risk register does not just help you test data. It's a communication tool. It keeps stakeholders, like it shows stakeholders what you are watching and what you are deprioritizing and why. It's not just a nice to have, like it's a very, very important document. So what does this document do? It helps with better communication. It's like a communication tool. It shows stakeholders what you are watching, what you are deprioritizing, and why. So all of that we captured in the risk document. So now let's proceed to the integrating risks into your test strategy. Now I know we are all aware of test strategy, test plan, and the likes, but now we have to integrate risks into our test strategy. So right now I want to walk you through how risk analysis should be fed into each artifact. Risk assessment, now visualize it. Risk assessment is at the top, an arrow pointing down. The next is test strategy. Test strategy is what will we test and at what depth. Then the next is test plan. What features, which environment, which cycles. The next is test cases, which scenarios, which data, what coverage level. The next is execution, in what order, what gets caught if time runs out. Reporting, what did we cover, what risks remain open. All of that should be in your test strategy. So let me go through this again. At the top, we have risk assessment, followed by test strategy, which covers what we will test and at what depth. Then it's followed by test plan, test cases, test execution, and reporting. So that's what our strategy, test strategy, is meant to look like when we integrate risks into it. Now, there is a key habit that I feel that we can all instill as QAs. Every time you choose not to test something, make it an explicit, documented, risk-informed decision, not just an accidental omission. I mean, you should have a reason why you did not test it. It shouldn't be because of chance. It should be that you looked at it, you calculated the impact, the likelihood, the risks, and prioritize or deprioritize the future. And it should equally be explicit, documented, and risk informed. It should not just be an accidental omission that you just forgot to capture. Going forward, let's look at risk communication with stakeholders. Testers often struggle to communicate risks to non-technical stakeholders. Now, there's an approach that I want us to use so we can communicate effectively with stakeholders, which is going to be very helpful. So this approach is the if, then, therefore framework. That's what you can call it. Use the if, then, therefore framework. So let me try to put it like in a sentence. If this condition exists, then this failure could happen. Therefore, we recommend doing X. If this condition exists, then this failure could happen. Therefore, we recommend doing X. So now, what is expected, I want to flesh it out a bit so we can have full understanding using a product or a feature. If we skip regression testing on the checkout flow this sprint, then a regression introduced in the new discount feature could silently break payment processing. Therefore, we recommend at minimum running the 15-minute critical path regression before release. So this is where we use the if, then, and therefore to communicate with stakeholders. Because I know they want everything to be live, and literally sometimes they want everything to be done their way. But we should know how to communicate with stakeholders using the if, then, therefore framework. Trust me, it always works. So we can also perform an exercise right now. Drop it in the chat if it's convenient for you. You can use the if, then, therefore method and use a particular feature. Just use a real life analogy and write this out. So that it will sound like my example I gave. And when communicating, let's say for instance, the stakeholder say that you don't need, there's a bug in the login feature where that is really critical. Relate it to the stakeholder using the if, then, therefore framework. So I expect to see like response in the chat so that I'll be sure that we have full understanding of this particular risk communication with stakeholders. Now let's proceed to the next part, which is common pitfalls and anti-patterns. This part is the we test everything fallacy. So some teams claim that they test everything. Well, breaking news, they don't. They just haven't made their trade-offs conscious. They feel they've tested everything, but trust me, they haven't made their trade-offs conscious. So I want us to have a reality check from my point of view. Time spent testing one thing is time not spent testing another. I don't know if you got that. Like time spent testing one thing is time spent not testing another. Let me say, for instance, you focus your energy on testing the UI. The UI is distorted, the font is not big enough, it's too small. And the time you are spending to do that, the high risk feature is sitting pretty and you are not testing it. You have unknowingly deprioritized the high risk area without you knowing. That's why we should always be conscious of how we test and deprioritize or prioritize. So the next scenario is pretending you test everything equals not owning your prioritization choices. Then the result will be that critical areas are under-tested because low risk areas consumed the budgeted time. That's what ends up happening. You unconsciously prioritize without you knowing. So what happens that if you don't intentionally prioritize, you just unconsciously prioritize. Now I want to move forward. Okay. Let me wrap up real quick. So testing what's easy instead of what matters. So this is the part where this is the part that is the least resistance in testing, where testers test what's easy to test, not what's important to test. It happens a lot. So let me just mention some signs that we know that is happening to us. You'll see that your test suite is full of UI tests or minor features. Happy path coverage is high. Edge case coverage is almost zero. Test automation covers only the stable old features, not the new risky ones. Exploratory testing never touches the new refactored areas. That's like most of the signs you know that you are just testing what is easy. And at the end of the day, you can be testing what you are comfortable with testing, not strategizing or prioritizing very well. So another topic I want to look at, I think I have like 3 subtopics and we can call it a wrap. There is the static risk assessment. We should know that risk is not static. What was like low risk last sprint may be high risk now because, for example, the code was refactored, a key developer left, new integrations were added, the user base scaled up dramatically, compliance requirements changed. So automatically, you see what was like low risk the last sprint, all of a sudden it became like a high risk this sprint. So let's just put it in mind that the risk is not static. So there's a habit we should build, like we can regularly revisit the risk register at the start of every sprint or release cycle, because the risk is like a living assessment, not a one-time exercise. So when there's a new sprint, just revisit your risk area and look at it, strategize accordingly, prioritize, calculate the likelihood and the impact so that you know your risk score for each particular feature. Don't just do it once. You don't just do it. It's not static. You always have to update it so that you be sure that you are prioritizing accordingly. So I want to move on to a different sub-one topic, which is treating all bugs as equal, which is something we commonly do. So not all bugs are equal. A missing comma in a tooltip and a data corruption bug are both bugs, but they are not equal. So I want us to look at a severity priority matrix, which I will just like read out to you guys. There is the critical, and for severity, for example, payment failure, data loss, and security breach. It falls under severity, critical, priority, high. Then for high, we have poor workflow broken for all users. Medium. When I say medium, just like severity and priority and medium. We have the feature broken for a subset of users. Low, UI misalignment, minor cosmetic issue, and the likes. Then we have low and deferred. Low priority, deferred, low severity, deferred priority. This is typo in rarely visited admin pages, all those parts that nobody touches. So you see that they are all bugs, but they are all prioritized differently. So a small misalignment and a critical bug can never be the same. So we should know how to prioritize. So quick question again before I leave prioritization based on different types of bugs. You can just drop on the chat which specific bugs from your experience would fall under a particular matrix, either critical high, medium, low. Just drop a bug and add the particular prioritize accordingly based on the criticality of the bug. Let's look at risk aversion versus risk management. Now, this is like, this words most times is just usually like read as the same thing to some people. But now I just want to state like the difference between the risk aversion and risk management. For risk aversion is refusing to release unless everything is tested. That's what spot paralysis. So there are a lot of testers in this category. Even if there's a small UI issue that doesn't disturb the product in any way, there's no impact at all. In fact, 0 or 1 to 0 impact. Some testers will be so fixated that if it's not fixed, it can't move to production. So that, like, they fall into the risk aversion category. Trust us, we don't want to be those testers. So what right now we are meant to do as modern testers that have known about risks and prioritization is to be under the risk management. Here, we are testing smartly. We understand the remaining risks, and we are making informed release decisions. Now, basically, you know there are risks. You take note of them. you document them equally based on all the steps we've been going through since the start of this section. And at the end of the day, the stakeholder, product manager, is aware of the issues left, because we know as QA, the absence of bug is a fallacy. So we should just ensure that the bugs that are there are the ones that fall into that have zero impact or one impact, like very minute impacts, like minor impacts to the product, not the ones that like is of high priority. So we document all of this, and it will be left in the stakeholders or product hand to determine if it's going live or it needs to be sorted out. But you should just do your work in prioritizing it based on its risks. So I want us to be informed that great testers enable release decisions. They don't block them. They say, here is what we tested. Here is the risks we've mitigated. Here is the residual risks that remains. The business should decide whether the risk is acceptable or not. So that's up to their hands. For you as a tester, you should do your own part. So this is basically a wrap. I have like few assessments that I might mostly drop on the chat if anybody is interested to like put their hands, like try out what they've learned so far in risk and prioritization in software testing. So one of them is that I want you to pick, you can just do it at your comfort zone, just play around. I want you to pick a particular product. Let me say OP, because a lot of people use OP. So let me say OP, for instance. The features you should focus on is the login, balance view, fund transfer, card freeze, notification, settings, and chat support. And now this is your task. Score each feature for likelihood 1 to 5, and impact 1 to 5. Then calculate the risk score. Now we know that I'm still giving you guys S score. We know that the risk score is calculated with likelihood and impact, which is likelihood times impact. That's where you get your risk score. So score these features. Your first task is to score the features for likelihood 1 to 5 and impact 1 to 5. Then the second task is calculate risk score. Then the third task is assigned to Moscow categories. You know where you must test, should test, could test, and won't test. Apply that. Then decide what to test. Finally, that's the fourth task. Decide what to test with a 4-hour budget. So with this, I'm just going to understand your understanding of risks and prioritization, because with this feature, you are meant to prioritize and calculate the risk score to be able to fix it, like to be able to prioritize accordingly. That's basically the focus of this assessment. So whoever does it, you can just send to our channel and you can tag me as well. I'll look at it, we can run through it, have any discussion around it. I'm open to hear your arguments, because it's going to be fun to see the perspective you are all coming for. And after this, I think we should just deal with just this one assessment. I had a lot, but this one is fine, it covers a lot. So I will call this a wrap. And at the end of this session, I already believe I've covered the key. I believe I've actually covered the key goals for this session, which the first one was for us to understand what risk means in the context of software testing. I've explained that. Then identify and classify risks using structured frameworks. Apply prioritization techniques to build smarter, leaner test strategies. Avoid common prioritization anti-patterns, and design a risk-based test plan for a real-world scenario. So with that, I think I can call this a wrap. And if there are any questions, it's dropped in our channels, because I feel we've spent like a lot of time. And if you feel you literally want to ask, if Mosumola is going to give us time to ask question here, that will be fine. If not, we can call it a wrap, and any question at all is going to be addressed. Thank you very much. Over to you, Mosumola.
Okay, that was actually a great session because I mean the the formulas was great for me actually. Thank you so much, Alexandra. Meanwhile, if you have any question, you can always raise up your hand and unmute your mic and speak. So we are going to be waiting for 1 minute. If you have any question, you can drop your question. Once again, thank you very much, Alexandra, for that wonderful session. That was actually great. I can't call it session. It's actually a great class. Thank you so much.
You're welcome. Thanks for having me as well.
My pleasure. So, guys, imagine even after thinking about the fact that oh, this is actually going to be a fireside chat, and it turned out to be a session, which is win-win. Okay, we have a question from Emo. I said, please, will the recording and the documents used in this session be shared with us? Yes. So we have the YouTube channel, and once we drop it on Monday, we are going to be sharing the channel with you guys on Monday. And also we are going to be speaking to Alexandra to share the document with us so that it can be easy. Yes, God will, God's will. You can unmute your mic and speak, please. Go on.
Hello, everyone. Good afternoon. I'm really excited for being here, and I don't want to ask a question. I just want to appreciate the speaker because most of what she said were terrible habits I used to use. When she said you want to test everything, so I really my main takeaway was the Moscow prioritization, and just prioritizing testing and not just testing randomly and making sure you're very detailed and defined when testing. So I just want to, show my appreciation for this session because, I mean, you think you know a lot until you come to classes like this and then widen your scope and understanding. So, and I also wish to have the recording in the future. Thank you.
Okay, thank you so much, God's will. God's will. As I said before, the recording will be on YouTube on Monday and it will be shared to our channel. Are you currently on our if you're not on our Slack, you can join us on using www.stesasporters.org so that you can have access to the video. Thank you so much for the God's will. Any other person have any other thing to say before we call it the day? Okay. Without further ado, and once again, I would like to say thank you very much to our speaker, Alexandra Michael, for this wonderful session. I mean, it was a great one, and you actually broke it down for us. I mean, there are some things I'm just hearing for the first time. I'm like, okay, that this thing I'm so going to implement it. Thank you so much, Alexandra, and thank you so much to everyone that joined us in this wonderful meeting today. I know that it is Saturday and most people would like to rest today, but it's still, you stay at the time for growth. Just so great. I mean, you should actually commend yourself on that. Thank you so much, everyone. Thank you so much, Alexandra. Thank you so much. I really want to appreciate our founder because without that this wouldn't be happening. Thank you so much, Princess, for this opportunity, and thank you all for this. Let's actually unmute our mic and say thank you so much to Alexandra and say our goodbye. Bye, everyone. Let's have a very nice weekend.
Thank
Thank you
you.
so much,
Thank you,
Alexandra.
Alexandra. Thank you.